Welcome to Manufacturing Talks with Jim Vinosky. Industry has a million cool stories, and Jim talks to the movers and shakers who are making them happen. Let's dive in.
Hello, and welcome back to Manufacturing Talks with Jim Vinosky. You know who I am, and I'm really happy today to be joined by Jason Brownell. He is Director of Engineering at a place called Molding Graphics Polyfuze. Welcome, Jason.
Thank you so much for having me. It's awesome.
I appreciate you being on.
You bet. You bet.
Good deal. And how are things out west today?
Cold. It
really?
Was, yeah, we're out in Arizona, but we're in central Arizona, about 2 hours north of Phoenix. And so when people hear Arizona, they automatically think, oh, it's nice and warm. This morning it was 23 Fahrenheit. It was 21 yesterday when I left for work in the morning. So it's not uncommon for us to once in a while have snow and things like that. So
I did know it gets chilly out there, but I would have assumed, I'm in Michigan, that it would be at least a little warmer, and that was almost the exact temperature I woke up to. So
oh wow.
Yeah,
pretty similar. I'm originally from Michigan before moving out here in first grade. So
okay, where are you from in Michigan?
Down in the southwest, kind of by Kalamazoo area.
Okay, yeah, not too far from me. I'm in the Grand Rapids area.
Oh, perfect. Yep.
And now you're in Arizona, and you are working for Molding Graphics and Polyfuze. So, obviously, there's not going to be a lot of people out there who've heard of this company, and that's one of the things to me that's fascinating is what you guys do, and really how familiar people are with your work without knowing it, right? So, tell us all about it.
Absolutely. I know I drive my wife nuts because we'll go on a vacation somewhere and I'm like, that's us.
Yeah.
Oh, that's us. She's like, I get it. But yeah, we're very much a niche company. There is a family of plastics known as the polyolefin family of plastics. And it's a very challenging material to try to decorate, and certainly to try to decorate it long term for 10, 15 years. And so under that heading of polyolefins, you have all your different polyethylenes, whether it's low density polyethylene, high density, ultra high molecular weight. This is also going to include polypropylenes, whether it's clarified or talc filled polypropylene, glass filled polypropylene. This is also going to include like soft touch type material, almost like synthetic rubber, like TPV material. Again, these are challenging materials to decorate, and that's where we come into play is helping people to decorate polyolefin type materials.
And so, obviously that's terminology you're familiar with, but a lot of people out there aren't going to know what you mean when you say decorate. So say more about that.
Yeah, absolutely. So if you think of a mop bucket or a rollout trash cart that you might take out weekly, to have trash service picked up, those are going to be examples of that specific type of plastic. And then, like in the waste industry, you may have a hauling company that you're working with. Well, they want to have their name on the outside of that rollout cart. That way, when it comes time for pickup, they can quickly identify, which receptacles are theirs. And so an interesting story along that lines, I was talking to a hauling company years ago, and, they were using a different type of decorating method, which is fine, and really didn't have any interest in moving forward with Polyfuze. And again, at the end of the day, we hang our hat on durability, that it'll be there 10 years from now. So I'll never forget it. It was the week, like I want to say December 28th, something like that. But it was during that end of year holiday season and all of that. And I received a phone call from the owner of the company. And he said, what do I need to do to move forward with getting Polyfuze on the side of my trash can? And I said, well, send me over some artwork, we'll put together some quotes, but I have to ask you, why now? Like, we talked a couple of years back, and he said, well, I'm actually running the route because many of my drivers are out and I can't identify my own trash cans, just because of failure modes in the field.
Yeah.
So yeah, we're never going to be a company to, decorate shampoo bottles or label shampoo bottles. Those, they have a lifespan of, say, 3 to 6 months. Where we're going to come into play is something that has requirements that it needs to be there 10 years from now, 15 years from now. And part of the reason why I throw out those numbers, 10 and 15 years, we see those kind of spec'd in various industries. For example, in the waste industry, they're looking for labeling that will survive for 10 years.
Right.
And that's what they consider the life cycle. In automotive, when you look at their permanent labeling and specifications, oftentimes they're looking for 15 years for end of vehicle life.
Yeah.
So again, that's kind of where those numbers are coming from.
Yeah. And so you mentioned a couple of areas that you're in there. So your average consumer, what kinds of products is that person going to see that'll have your work embedded, so to speak?
Yeah, for sure. And then I'll kind of explain the technology too, and why it's used on those products. But, we do a lot of work with companies like Rubbermaid, for example, where durability, they want their brand out there. They want it out there for the life of the part. And that's where we come into play. I did mention automotive. We work with companies like General Motors and Ford Motor Company, because again, we have a durable solution for that type of plastic. But we're involved in the medical industry. We're involved in outdoor sports. You see us on a lot of different types of kayaks. You see us on a lot of different types of coolers, again, in the outdoor sporting industry where something needs to survive harsh environments.
Yep.
So the reason, I guess, why people come to us, again, a lot of times, initially they will come to us because they may be having failures in the field. Where their current decorating method or labeling method is failing for one reason or another.
Yeah, and people see that themselves out here in our world, right? People have labels peeling off and graphics that become unreadable. That's what you got to solve.
We do, and again, oftentimes it's about, number one, branding. Branding is important. When you see that cooler that you really like, you want to know where it came from, and so that you can go purchase one yourself. So branding is one area that's very important for a lot of people. But then also like warnings and instructions on how a consumer should use a product. Maybe if it's not used properly, it might be potentially dangerous. And so it's important to have warnings and things like that to share with the consumer of that product line. So when it comes to polyethylene, polypropylene, TPB, the polyolefin family, and nothing wants to stick well to it long term. And we don't stick to it either. And it's kind of funny because, I'll send a sample to somebody and they'll go, wow, your guys' labels stick really well. I'm like, they don't stick at all. Right. And then there's kind of this confused sound on the other end of the line, but we're not adhering at all. And so when you look at typical labeling methods, or decorating methods of these types of materials, you have, number one, just a good old-fashioned sticker. You're trying to adhere it to that surface. And there's a bunch of reasons why nothing wants to stick to this material. In fact, low surface energy is probably the biggest one. And when you look at things like steel, for example, when you're calculating surface energy, you do it in what's called dynes per centimeter. And dynes per centimeter for steel is going to be like somewhere around 700 to 1,000 dynes per centimeter. Glass has a very high surface energy. And so those types of materials, adhesive technologies work really, really well. Mm-hmm. So again, when you compare 700 to 1,100 dynes per centimeter, polyethylene and polypropylene come in there at around 30 dynes per centimeter. Yeah. So it's incredibly low. In fact, I think Teflon coating, which we use to coat cookware so that nothing sticks to it, is at about 18 dynes per centimeter. So polyethylene and polypropylene is super hard to adhere to because of that.
Yeah, so it explains in that very geeky way, which I can appreciate because I'm a mechanical engineer, but obviously a lot of our viewers just thought, what the heck is he talking about? But it's why if they try to tape something to a piece of polyethylene, it's not going to stay there, right?
That's right. And you know, people will, go to the hardware store. They'll try to find a paint that will stick to the material. And again, because of that low surface energy, it can certainly be a challenge. The other thing is polyethylene, polypropylene, it's constantly expanding and contracting when it gets hot and when it gets cold. And I use the analogy there. It's kind of like putting a Band-Aid over your sticker or over your knuckle on your finger. And then as you start to flex, it wants to come off. And then if you add moisture of any kind to the equation, then it wants to come completely off. And so that's kind of the analogy that I would use when you try to use an adhesive technology on polyethylene and polypropylene, which is expanding and contracting. The other thing is these materials have outgassing that is occurring. It could be, due to blooming agents or surfactants, but just the composition of things and the manufacturing process causes them to outgas for a period of time.
Stuff that's in the plastic itself that's working its way out. So, if you try to take and put, say, a sticker or a pressure sensitive adhesive label onto that surface, you might notice a bubble that starts to lift.
Yep, exactly. And again, that could be caused by outgassing. And oftentimes when I go into, say, an injection molding facility, I will see staging areas set aside after it's been manufactured. It's sitting in staging, waiting for that to outgas. Before you try to put a sticker or some type of adhesive technology on it. Does that all kind of make sense?
Yeah, it's great background, and it actually goes back to kind of the founding story, right? So it was your founder who realized this was a problem and wanted to solve it, and now we get into, okay, how do you guys do your thing so it doesn't happen that way?
Yeah, and if I understand the story correctly, there was a major restaurant chain who was having issues with the labeling falling off their creamer and their coffee dispensers. And so then they were getting flip-flopped and so or their milk dispenser. And so now all of a sudden you have kind of coffee flavored milk and it was an issue. So that was a challenge that really kind of got things going, was trying to find a solution for that.
So kind of mad scientist action in his own garage lab.
It is truly an amazing story, and there's a piece on our website about it.
And I wrote about it at Forbes. So if you want to read the story, look up my name and Molding Graphics and Polyfuze, and it's a great story of a guy building a great family business. But I want you to continue with what you were saying, because you guys, you came up with just a genius solution, right?
For sure. So the secret ingredient, if you will, to our technology is heat. and we're taking two like materials and we're heating them up, and they're fusing together. And so before I get too far into our technology, I kind of also would, if you don't mind, would like to talk a little bit, we talked about stickers, but other methods that are out there.
Sure. Yep.
And kind of how it relates, because then once you understand that, you can see how different we are to those other types of technologies. So again, stickers are trying to adhere. You have heat transfers that will be utilized in this industry. Again, if you look at the construction of a heat transfer, oftentimes you will have a clear coat on top, followed by a layer of ink, followed by a layer of adhesive, and again, trying to make it stick to something nothing wants to stick to. And then next up would be kind of like hot stamp foil. And to that, I would include pad printing or screen printing. Again, they're trying to use an adhesive-based technology, trying to make it stick.
Right.
And then lastly, we see in-mold labels, which there is a mechanical bond that happens between the substrate and the base plastic, which honestly is a really, really strong mechanical bond. The trouble is, if you look at the, again, cross section of how they're typically made, you would have clear coat on top, followed by a layer of ink, followed by that substrate. So the trouble is, if that clear coat breaks down for whatever reason, could be due to being in an abrasive area, or could be UV, maybe this is an outdoor application, but if that clear coat breaks down for whatever reason, then that exposes the ink. And then if the ink ends up going away, and at the end of the day, you're left with a substrate on the part, but some of the labeling or the verbiage that may have been on that substrate goes away.
Yep.
So again, but all of those different methods are things that we see and failure modes that we see in the field.
Right. Yep.
So that's where we really come into play. I mentioned at the beginning that we're very much a niche company, and that we work with only the polyolefin family of plastics. The only time that we get outside of the polyolefin family, we do have a solution for people that are working with flexible PVC. And so, if any of the listeners, have an application like that, that's the only time we get outside the polyolefin family.
Yep.
So what we provide here and what we print here is a thin layer of plastic. That's it.
Yeah.
It's not ink at all. It is a thin layer of polymer.
Yep.
And then we're putting that in contact with the plastic part. And then we're using heat to reach the melt temperature of the plastic label, which is going to be somewhere around 300 Fahrenheit. You're going to reach the melt temperature of the part itself, or the skin of the part itself. Again, polyolefin family is going to melt somewhere around 300 Fahrenheit. So everything is going to turn into a liquid state for a brief period of time. And we're talking like maybe 1 to 2 seconds. So then it cools and it solidifies. The carrier film that we printed gets removed from the part. And now you have a label that is part of the plastic. You've reached the melt temperature of the two materials.
Yeah.
Makes sense?
That's the key to it, to me, is that now it's part of the part. So it's not a separate label. It's never going to peel off. It's truly part of the plastic of the part itself.
It is. And I watch people, like I'll give them a plastic part that has a polyfuze or molding graphic, and 99% of the time they go to the corner and they start trying to lift it up. And it's like there's nothing to delaminate. I mean, it's part of the plastic.
And
I would say if you had to compare us to another process, we would be more closely related to plastic welding
Right. Yeah.
than we are any sort of decorating method. Because again, with plastic welding, you're taking two thermoplastics, reaching the melt temperature and pushing them together. So,
Yep.
and that's exactly what we're doing here.
Yeah. So now, as director of engineering, what does that mean for you? What are you doing day to day?
Day to day, I work on solutions with customers. I do, troubleshooting, field work. Oftentimes if somebody's brand new to our technology, I may come on site and help them with getting their equipment set up.
Mm-hmm.
It's a very, very repeatable process once you have the recipe put together, if you will. Again, all plastic is, they're going to have different melt temperatures, different characteristics. Where you decide to label a part can impact the process as well. Like, for example, if like on the Polyfuze side of things, it utilizes a hot stamp machine or a heat transfer machine, something that, is utilized in the industry already.
Right.
The setup of that equipment is going to be totally different than if you were using those other technologies.
Yeah.
Because again, we have to reach the melt temperature of the two material. So we're going to set the machine at about 550 degrees Fahrenheit. And earlier I was saying that, polyethylene, polypropylene is going to melt somewhere around 300 Fahrenheit. So you could theoretically come down on top of the label with 300 degrees and eventually the two will melt together. But that's not very efficient. So we're going to throw more heat at it so this job can get done in a second or two. So we have to reach that melt temperature in order for it to work. So if you take a hot stamp machine, heat transfer machine, and put it at the end of an injection molding work cell, and the part is coming out and it's warm. Maybe the part is 120 degrees Fahrenheit. Well, then it's going to take you X amount of time to get from 120 to the melt temperature of 300. Conversely, if we pull a part out of a 45-degree warehouse and we want to do the process of polymer fusion, it's going to take longer for us to reach that 300 Fahrenheit because we're starting so low. Right. It can be done, but it could add a couple seconds to the process, if that makes sense.
Yeah, and what's interesting to me, because I come from a very different part of industry. I've worked in mostly food processing myself, and I think of a director of engineering, and his focus or her focus is going to be more on internal processes, where you're very much involved in your external partners and what they're doing in their sites, because that's where your stuff's baked into the equation, right?
Correct. And yeah, we're the only company that I'm aware of that is doing anything like this. Yeah. So when we work with customers, especially new customers, this is totally new technology for them. And for somebody who maybe has worked in plastics manufacturing and they're familiar and worked with hot stamping and heat transfer, if there's any sort of issue using our technology, they want to revert to what they know. And if they have 20 years experience working on a hot stamp machine, well, they're going to use that experience. But our technology is so different that oftentimes you need to go a different direction. And so that's where, I can come in and help support them and help to educate them. Cool.
So are there any kinds of major technical challenges? You talked about temperature and all of that, but anything that potential customers should know as far as like size of equipment or different extreme applications that maybe would be a particular challenge? Anything beyond just your normal day-to-day that people ought to be thinking about if they're thinking about using you guys?
Yeah, for sure. And maybe this would be a good time to kind of understand kind of where we've come from.
Yeah.
I've been talking a lot about injection molding and what I see on the injection molded side of our business. But so you mentioned molding graphics, you mentioned Polyfuze. So molding graphics is actually an in-mold solution specific to rotational molding. And so a lot
so describe rotational molding. I actually remember reading about that. I didn't know about it at the time, so I looked it up, so I know what you're talking about, but tell other folks what that's all about.
For sure. And so just as the name implies, with rotational molding, you have a mold, which is, opposite of the part that you're making. So if you want to make a kayak, the inside of the mold will look like a kayak. And then you would pour in plastic resin into that mold. And the amount of resin you put in determines the robustness of the wall thickness, how heavy the part is going to be. And so you add resin into this mold. Then you close up the mold because it's usually in two halves, or it could be, multiple parts to a mold. But for sake of illustrative purposes, we'll just say it's two halves. You got a part down here and a part up here. You pour your plastic in, you close up the mold. It then goes into a rotomolding oven that is running at about 550 degrees Fahrenheit. And so it is rotating like this on an arm, but at the same time that it's rotating this way, it's rotating this way. And so, it's rotating in all directions. And so what happens then is the plastic reaches it, or the resin reaches its melt temperature, and it begins to coat the inside wall of that plastic mold, or the mold for the plastic part. And after a predetermined amount of time, it comes out of that oven and it goes into a cooling chamber where it will continue to rotate while it solidifies. And so mold in graphics is a labeling solution where you take our plastic label, if you will, and you put it in the mold. Then when the part comes out, because you had it in that 550 degree oven, those two materials melted together. So when you pull the part out of the mold, it's now permanently labeled for the life of the part. And when I first started here, which I believe I've been here 26 years, something like that, 27 years. So it's a fascinating industry, and I love it. And so all we had at that time was a molding graphic. And then we realized, we were really limiting ourselves to only going into a rotational molded tool. And sometimes when a person is making a rotomolded part, oftentimes they're very big parts or large parts. And maybe where you need to put the label is in a place where it wouldn't be safe to have an operator going into that portion of the mold. Or maybe you want to put a label where the two halves of the mold come apart. Well, you can't do that if you're doing it in the mold with our system. So that's when a mold on graphic was developed, where everything is printed now in reverse so that you can put it onto the plastic part. But now it's just a raw material laying on the surface of the part. It's plastic, it's polymer. And so somehow we need to melt those two materials together. So that's done with a shrink wrap torch. And so you hold a shrink wrap torch in one hand, an infrared pyrometer or thermometer in the other hand, and you start heating it up. And what you're going to see happen is that the label itself, the surrounding plastic, is going to start to look wet. And when you see that, it's because you've reached the melt temperature of the two materials. You just take the infrared gun and verify that you're up and over 275 degrees or 300 degrees Fahrenheit. And now it's part of that plastic. And so if you go to our website, and you mentioned this before, that it is actually fused together. We sent off, and it's definitely on the Polyfuze site, we did SEM analysis, where you take and you do a cross section of it, and then you come in with a high-powered microscope and you look at the different layers. And we did that for various types of materials, like a pressure sensitive, adhesive, type label. And you can definitely see like the striations. Okay, well, here's the part, here's the label. But when you look at a Polyfuze or a mold-in graphic under high magnification, you'll see that it's like part of the polymer matrix now, that they're actually melted together.
No, now I'm just going to have to pull that up while we're sitting here.
Yeah, go for it. Yeah, semanalysis. So that was pretty cool. And so we started with the mold-in graphic. It moved into a mold-on graphic, put onto the surface. And then we realized that people in the injection molding industry needed us as well. The trouble is the mold-on graphic takes a little bit of time. And by time, I mean, maybe it takes you 30 or 40 seconds to put on a label. Maybe it's a minute. But if you're dealing with a cycle time, like in rotomolding, where maybe you have 20-minute cycle times, spending 30, 40 seconds, not a big deal. When you get over to the injection side of the equation, it's a much, much faster process. So we didn't have a solution for people in injection molding until we developed the Polyfuze label. And again, that's why you have the mold-in graphic part of it, and then the Polyfuze side. Polyfuze is primarily for injection molding, and it's a very, very fast process. Go ahead.
Yeah. So for folks who aren't familiar with that, injection molding's how pretty much all your small plastic parts are made, where you got multiple molds, and it's just hammering away hundreds and hundreds of parts at a time.
Absolutely.
Really flying. Yeah. So think about what people have learned here today. Number one, how you've taken folks away from labels that peel off and get attacked by water and chemicals and things like that, made your graphics part of the plastic part. Plus they learned that a kayak is made in a big giant mold that rotates in all different directions while it's being heated.
For sure. And
across the board.
That's right. And that's not to say that there aren't blow molded or thermoformed kayaks out there, but yeah, that's a perfect example.
Well, I love that. I love that example, because when I looked it up, I remember they were making some big, huge bin, and this thing had to be, 4 feet on a side. And even with my background in manufacturing, it kind of took my breath away that they're throwing these big, huge molds around to make these big plastic bins. For sure. Cool. Well, so in addition to the phenomenal work that you're doing there that you just told us about, so you're big into music too. I read that on some of your online info. So tell us about that.
I am, yeah. Boy, I started playing drums at the age of 4, and part of how that kind of came to be is I was at a parade, and I was watching the marching band come by, and I was fascinated with the guy that had that big bass drum strapped to him, and he's just pounding on that thing, and I thought, I want to play that. And so when I made my list, I wrote down the only thing I knew, which was a drum set. And that's what I got, was a set. And I was just expecting to just get the big one, but I got a whole kit. So I didn't want to be unappreciative. So I tried to, first I was like, how am I going to strap this on? It's meant to sit on the floor. So anyway, I started playing drums. By the time I was 10, I was playing 4 nights a week in nightclubs. And so yeah, then I learned how to play like bass guitar and regular guitar and pedal steel and piano and all that kind of stuff. So it's definitely a passion of mine. That and food. I love preparing food, and it just kind of helps me. Both of those things kind of help me escape a little bit and get to use the creative side that I enjoy using at work. So yeah, food and music. Those are two biggies.
Yeah. So we've talked about what you guys have done, you know, kind of where you came from and what you're working on now. And I know there's some really, really cool stuff going on, both with molding graphics and Polyfuze, plus beyond that. So for my article, I got to talk to Jennifer, and then also got to know her daughter, Noelle.
For sure.
And so Jennifer's off building a hotel there in Sedona.
That is
right?
correct. That is correct.
And I looked that up online. I'm pretty sure it's such a very nice hotel. Someone like me would never be allowed in it. It looks fabulous.
I don't know that that's true. You're fantastic. Appreciate the relationship, but yeah, I don't know all the details, but I know it's kind of a it's pretty special for North America to have that type of a home or a type of a hotel. So yeah, it's pretty cool.
And then Noelle's working right there with you at Molding Graphics.
Absolutely. In fact, you might even be able to see her in the background over there.
Well, they're such a wonderful family, and you know, certainly gave me a great education into what you guys are up to. And so what's next for Molding Graphics and Polyfuze? What's coming down the road for that end of the business?
You know, again, with our technologies, most of it has been driven by our customers, and we do have an R&D team here, and they are, you know, constantly developing and listening to our customers and what their needs are. So I'm sure there'll be some fun stuff coming down the pike in 2022 for sure.
Excellent. So Jason Brownell, Director of Engineering at Molding Graphics Polyfuze, thank you. This has been a great discussion and a great education. I got to write about the company, but you've certainly given me an even deeper look into the technology, which, as a geek myself, mechanical engineer, I deeply appreciate. Hopefully everyone else got the gist of what you were talking about, because I think it's phenomenal. You know, I just love the story of someone kind of going into a garage and figuring out this kind of big problem where he builds a whole family business around it, and here it is, still going strong decades later. So thank you for being here. This is Manufacturing Talk. Oh yeah, thank you. This is Manufacturing Talk. So definitely, if you enjoy what we do, get out there on YouTube, check out the channel, follow us there, follow us on your favorite podcast outlet. We're on all the major ones, and tune in every first and third Tuesday of the month for coming episodes for great folks like Jason. Thanks again, Jason.
Thank you. Appreciate the opportunity.
Yep. Take care.
You too.
Well, come on. It's not letting me get to the button to stop recording. I'll edit that out, obviously.
Thanks for tuning in to Manufacturing Talks with Jim Vanoski. Watch for new episodes dropping on the first and third Tuesdays of every month.